Hi, hello everyone. How are you all? Hope you all are doing well with your best stuff. This is Sham. Today in this video, we are going to discuss about position of an object. Okay, for example, I have an XY plane and XYZ axis here. For example, we can call this one as X axis. This is Y axis. Okay, and combinedly we can call this one as XY plane or else XY axis. Okay, don't be say like that. Spelling of axis is wrong. Okay, axis is singular, X axis. Okay, axis is actually plural. Clear my point? For example, first topic here it is position of any object. If I want to locate this X and Y in this plane, if I want to locate any position like this, okay, this point is called as origin. Already you went through with this topic. Right now, origin means here two axes are there. One is X and one is Y. So we can call this one as 0, 0. Only X and Y axis. Correct now? X value also 0, Y value also 0. Okay, this position we can call P of X, Y. Means it says that point P is located in X axis. Where it is located? In X axis, it is located at this position. Or else at this point. Okay, this is X. Okay, in Y axis, it is located somewhere else here. Correct now? This position is represented by here P of X, Y. This is having only X and Y axis. For that reason, we are writing only P of X, Y. What if I will take the axis also? Three axes present here. One is here, X axis. We'll mention one by one. X axis, look at above. And this is Y axis. And third one, we can call this Z axis. Three axes are there. It is actually 3D. For example, if I want to mention any point, this point P, I want to go with here X, Y, Z. Clear my point? Means along the X axis at X distance, Y axis, Y distance, Z axis, Z distance. Clear? Good. Next to that, we'll go with coordination geometry only. Here we'll solve like a position of any object from the origin. We'll calculate the distance. Okay, na? We'll calculate distance. Position formula, its distance. No problem. We'll go one by one. For example, this is X axis. This is Y and this is Z. For example, there is an object which is at this point. I will call P1. Okay. P1 coordinates are X1, Y1, Z1. Okay. It is moving to some other point. The object is moved from one point to another point, we'll say, na, like that. I'm going from P1 to P2. Okay. P2 positions are X2, Y2, Z2. Okay. Now I want to know what is the distance traveled from P1 to P2. D distance I want to calculate. Okay, how to calculate this D distance? Okay, now I got to know that P1 and P2, these two are positions. P1 is called initial position. Very important, this is initial position. P2 is called actually final position. Okay, in a 1D motion we'll start. In that topic, in that particular chapter, we'll use position and distance. Both are not same basically. For that reason, I'm informing here itself. Clear my point? Okay. Now I want to calculate P1 to P2. Distance I want to calculate. Simple, we'll do one thing. Look, this P1 is actually position of X, Y. There is no Z coordinate, extremely sorry. We are not taking here Z coordinate, only X and Y will take. Okay. In X axis, it is located here. I will call X1 and final position of X will be here. I will call X2. Okay. And then initially in Y axis, it is located here, Y1. And finally, it is located in Y axis. At this point, we can call Y2. Correct now? Look at this one carefully. If I draw this line now, okay. here this distance is actually change in position in y-axis. Correct now? Change in position in y-axis parallel to y-axis. You might be understanding, right? This y-axis is equals to here. Correct. Now I can write this change in position as y2 minus y1. And during that time, this object moves from x1 to x2 here. This change in position can be written as x2 minus x1. x2 minus x1. We understand. Okay. Now, in this triangle, I will write the triangle here separate. This is a triangle which we have. Okay. Now, this bottom means adjacent side, it is represented by x2 minus x1. Opposite side is represented by y2 minus y1. It is looking like standard right angle triangle. This is the distance d. If I want to calculate this distance, I can apply here Pythagoras theorem. It's very simple. So simply we can say d square must be equals to x2 minus x1 whole square plus y2 minus y1 whole square. And if I want to calculate d, it's simple. Take that square to right hand side. It will become under root. So answer will be x2 minus x1 whole square plus y2 minus y1 whole square. Clear? Simple. Going forward in coordination geometry, if they are asked by changing position of any object, if they'll ask what is the distance traveled, do one thing, take under root of x2 minus x1 whole square plus y2 minus y1 whole square. If they ask only the position in terms of direction, do x2 minus x1 plus y2 minus y1. That's all. Done. Hope it is clear. Correct now. Now, if they'll ask for three-dimensional geometry, for example, this is first position. This is second position. First position, it is including with P1 is including with x1, y1, z1. Okay, and P2 is the final position. It is included with x2, y2, z2. Means it is a three-dimensional geometry. Correct now? In that cases, whatever the distance it traveled in three axes also, if I want to calculate this distance, we'll write the formula like this. Distance will be equals to under root of, in terms of x-axis, we can go with here x2 minus x1 whole square. For y-axis, we can write y2 minus y1 whole square plus for z-axis, we can write z2 minus z1 whole square. Okay, these are all the values for x, y, z separately. By using this format, we can calculate the distance. Okay, hope it is clear. Pakka? Will we calculate on problem? Okay, this coordination geometry is not required in order to calculate. Let it be, but I will give the data and will calculate. For example, initial position, A position I will give 1, 2, 5. Okay, now, and it is moving to the point B. B points can be written as here 3, 4, 6. Now I'll ask, what is the distance between these 2 points? Means from A to B, what is the distance we need to calculate? How to calculate? It's very simple, sir. Now only you actually explained. Distance in terms of 3 axes also we need to write. 3 axes means the formula will be everyone. x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Clear? This is the formula. Now look this one. Here it is x1, y1, z1. This is x2, y2, z2. x2 minus x1. 3 minus 1 square. 3 minus 1 is 2. 2 square means it will be 4. Correct now? Plus. Next y2 minus y1. y2 is 4. y1 is 2. 4 minus 2, 2. 2 square means again 4. Good. Plus z2 is 6. z1 is 5. 6 minus 5, 1. 1 square will be 1. So answer will be 9, root 9. If it is come out of root 9 means distance is 3. If they given in terms of meter means you will write here meter, or else I will write this one as in terms of units. Then in this pattern, we have to calculate the problems. Okay, now. Next, very important, that is slope in XY plane. What you called slope, by the way? Slope. For example, this is horizontal line. What is this? This is horizontal line. Correct now? If this line we can call X. With respect to this line, I'm increasing this axis like this. Okay. Now with respect to the original line, it is creating some angle, right? We call this one as slope. As it is increases, slope also increases. Simple, if I want to say, for example, like this is a line. Okay. What is the slope here? No slope. It is exactly horizontal line. It is horizontal line. So horizontal line means the slope value or slope will be equals to 0. No slope is existed. If I will do one thing, this O point is there now, I will keep that point as a fixed. And this A point I will rise upward direction. As it rises upward direction, it will come like this. Means it is inclined by an angle of theta. Now it has a slope. Correct now? I will call this one as slope 1. Now, if I'll increase, theta will be increases. I will call this theta 2. This is theta 1. Now, I will call this line as slope 2. Correct my point? Now tell me, which slope is greater? Obviously, slope 2 is greater than slope 2 is greater than slope 1. Correct now? Means as the line is inclined, the slope will be increases. Simple. One more point. If angle increases means slope also increases. Will you agree? So I can say here theta 2 is greater than theta 1. Or simply I can say slope is directly proportional to theta. As theta increases, listen my words what I'm using here. As theta increases, okay, slope also increases. Done. Hope it is clear and understood to everyone. Good. Now coming to the point. Now actually I told 2 points here. What is that? This is P1 and this is P2. Okay. P1 can be written as x1 comma y1. P2 can be written as x2 comma y2. These are the values, position of the particle in x and y plane. This is x, this is y plane. Okay, if in case these two line joining point is called distance, two position between line we call distance. Now P1 is located actually at this point in x-axis, we can call x1. Along the y-axis it is located here, we can call y1. P2 is located in x-axis somewhere else here called x2, and in the y-axis it is located here, we can call this position y2. Okay, now I told you one thing. What is that? Slope. Slope is nothing but inclination. Now look here once. This line is making an angle theta here. Correct now? It is making an angle theta. So it has a slope. That's all. Correct my point. Basically, you studied, might be, I think you studied slope in 10th standard, or else no problem. Just we go with some flows what I'm going to say here. Slope basically proportional to theta, I told. As theta increases, slope also increases. Theta increases, slope also increases. So we call this theta is equals to or else proportional to tan theta. What we call tan theta. Simple. Tan theta means for this angle, we need to take here opposite side by adjacent side. Correct my point? What we need to take? Opposite side by adjacent side. What is the opposite side, by the way? Sir, opposite side is actually y2 minus y1. Adjacent side is x2 minus x1. So shall I write like here? Y2 minus y1 divided by x2 minus x1. That's all. Slope is nothing but theta. Which theta? Tan theta. Why? We are taking opposite by adjacent. We are taking opposite by adjacent. Opposite is y2 minus y1. What is opposite? It is y2 minus y1. Adjacent is x2 minus x1. Correct now? Y2 minus y1, shall I write? This is change. Change can be written as delta y by delta x. What we can write? Delta y by delta x. Simple. If it is very small, it is actually greater values. What we took here, it is very greater value. Correct now? If it is very small, then this delta y by delta x can be written as dy by dx. Okay, these are all our formula for slope itself. If you want to calculate slope, simple. Once again, we'll go with very important final I'm writing here. Slope actually calculated. Generally, it is represented by m. Going forward, I will tell you. Okay, slope is represented by small m in mathematics. Okay, it is nothing but tan theta. In a graph, slope is nothing but tan theta. Okay, and then this tan theta is nothing but opposite by adjacent side. Whatever you want to write it. There is no problem. One thing you may write this one as y2 minus y1 divided by x2 minus x1. Y-axis difference by x-axis difference. Or else you may write this one as delta y by delta x. Or else you may write this one by dy by dx. Whatever it might be. Dy by dx, it is used only when there is a change takes place in x and y, the two very small. I will tell you where we need to use and everything going forward. But whatever I'm actually implementing here, please keep that points in your mind. Okay, that's great. Next to that, positive slope and a negative slope. I will tell you very dearly how to identify positive slope and negative slope. Don't worry. Okay, now tell me one thing. Slope means how will measure slope? In a simple word, you need to express slope. It is nothing but tan theta. It is nothing but tan theta. Correct now? Next to that point, simple. If tan theta is positive, tan theta positive. Okay, I'm writing that one here. Note point. Very important. Listen carefully. Now, I mentioned here positive and negative slopes. Okay, slope is directly proportional to tan theta. Slope, if slope has to be positive, then tan theta should be positive. Correct? I can say here, if tan theta is positive, slope, that is m, is positive. Agree? If in case, this is I'm writing if case. Okay, if this tan theta is negative, if tan theta is negative, then m, that is slope. M stands for slope, that is negative. Understanding my point? M stands for slope. When slope is positive, when slope is negative means if tan theta is positive, then slope also positive. If tan theta negative, slope also negative. Clear? Okay, we'll go here. We know 4 quadrants also. Correct now? In first quadrant, all are positive. Basically, all are positive. Okay now? For example, I'll write one line like this. I'll just take an example. Random line I will write. Because I'm not going with any graphs here. These are random line. With respect to x-axis, it is created an angle here, theta. Correct now? Now tell me one thing. In this quadrant, this is first quadrant. Correct now? Which quadrant it was? First quadrant. In first quadrant, all trigonometric functions are positive. Correct now? Now tell me, in this quadrant, tan theta also positive. If tan theta is positive, the slope also positive. I think it is clear. Slope is understood, right? Where is slope existed by now? It is existed in where? First quadrant. That's why it is positive. Done. Clear. Now I'll take one more. Concentrate this. What is this? The red color. Color problem. Cool. Now look that one line. This is the theta, right, which is making from the x-axis. Theta. Now tell me this theta is positive or means it is less than 90 degree, right? Correct now? Here tan theta is positive because that theta is less than 90 degree. Right? Now tell me this is 90 degree, but line is coming from third quadrant. If the line is existed in third quadrant, now tell me one thing. Here already tan theta is positive. Correct? We learned in the last video. Means now tell me this line, white color, what I'm tracing here, is it having positive slope or negative slope? Obviously, because tan is positive, slope also here positive. Clear? I think it is clear. Okay, now when do you get negative slope then? Where do you get negative slope? Correct now? That is also very important question. For example, we'll write here like this coordinate system. Now I'll take a line. Look at this line carefully. This line is going like this, straight line only. It is also having slope. Okay, from this x-axis, x, this is y. Okay, this line actually making an angle here like this. Don't be think like that, sir. Second quadrant, not like that. This theta with respect to x-axis, what it is making? It is making greater than 90 degree. Greater than 90 degree. Greater than 90 degree means in which quadrant it will be false? It will false to second quadrant. Correct now? Now the line is existed in second quadrant. Correct now? Now tell me if it is in second quadrant, here which are positive? Sine positive and its reciprocal cosecant is positive. Correct now? What about tan? Negative. So now tell me here for this line, tan theta basically negative because it is existed in second quadrant. If tan theta is negative, slope also negative. Hope you understand what is the nature of slope and how it is existed. Slope is represented by m. Finally, slope is nothing but here m. Slope is measurement of tan theta. Simple. Done and dusted. Clear? What is nature of slope? I explained positive slope and negative slope. If tan theta is positive, then slope is positive. If tan theta is negative, slope is negative. Hope you all understood the topic which I explained here. Correct now? If you have any doubt, please you may ask me at any time. Okay, we'll solve one problem and then we'll wind up this session. Okay, yeah. The question is very simple now. Actually, there is a slope. It is passing through the points. I will write the question. Slope passing through a point A of 2, 4 and B of 3, 8. Okay, they're asking actually calculate the slope. This is question. Okay, what we need to calculate? Slope. How to calculate the slope? So first we need to write the coordinate axis. It is in x and y. Both are actually positive x and y. So we'll do one thing. A point here it is, what is the value? 2, 4 and B point is here 3, 8. Okay, now we have to calculate the slope value. How to calculate slope value? Sir, you only told actually now. Slope is nothing but tan theta. It is nothing but delta y by delta x. It is nothing but y2 minus y1 divided by x2 minus x1. Check once the question it is in which pattern. Based on that pattern, you choose the what is that formula to calculate the slope. Now it is actually in terms of x comma y, right? This is x1 y1. This is x2 y2. So you have to choose the correct format. Okay, correct format means now the slope is equals to, we can go with this formula. Simple, right? Now we can write slope is equals to y2 minus y1. y2 is 8, y1 is 4. So we can write here 8 minus 4 divided by x2 minus x1, 3 minus 2. So answer will become here 8 minus 4, that is 4 by 1. So slope nothing but m is equals to 4 we can write. Correct now? In the same question, they might be asked like find the angle. What you will do if they will ask find the angle for this slope? Simple, sir. Angle means this is the angle which they are actually asking, theta. Sir, it is very simple, sir. Slope is nothing but tan theta, right? Correct my point. Slope is equals to tan theta. Sir, simple. The tan theta value means slope value only here it is 4. Obviously. So I will equate these to them. Correct now? So theta is equals to tan inverse of 4. This is that. Check. Whatever you want, you may calculate. Unknown by giving based on the given data, you may calculate anything here. Hope it is understood. Okay. We'll meet in the next video. Until then, take care. Bye bye.